Welcome to today's lesson on modeling truthful state. By the end of our time together in this lesson, you will have a deep understanding of the MIRO framework for diagnosing state modeling problems. You'll be able to identify the four specific ways your data model can lie to you. And more importantly, you'll know exactly how to apply specific refactoring techniques to fix each type of modeling flaw. Finally, you learn how to design state models that stay truthful as your requirements evolve over time. Let me start with a quote that every senior engineer has learned the hard way. The fastest way to create bugs is to let your data lie. If you've ever been on a 2 a.m. incident call, you know exactly what this means. State is the beating heart of nearly every software system we build. When the shape of that state begins to drift from reality, problems don't just appear, they metastasize throughout the entire system. User interfaces start misreporting information, APIs begin contradicting each other, and your business logic grows increasingly dangerous. Conditional statements just to cope with the inconsistencies. Now, you might be wondering why state model deserves this special attention when we have so many other concerns in software development. Let me explain why this is actually one of the most critical skills you'll develop. First, there's reliability. Bugs that corrupt data rarely die quietly in your unit tests. Instead, they lurk in the shadows until they poison your production environment, often in ways that are extremely difficult to trace back to their source. Second, there's cost. When you make mistakes in the state model, those mistakes don't just disappear. They get persisted forever in your databases, your backups, your caches, and your analytics pipelines. Every copy of that bad data becomes a potential source of future problems. Third, there's velocity. Every sprint, your team adds new features to your system. If you have a brittle state model, each addition will take longer than the last. Technical debt compounds, and what should be simple changes become complex, risky endeavors. This is why I want to emphasize that a truthful model is the highest leverage design investment you can make in your software system. Before we dive into the MIRO framework itself, we need to establish a common understanding of what we mean when we talk about state. State modeling requires recognizing four distinct layers, and understanding how these layers relate to each other is crucial for building robust systems. The first layer is what I call the real world state. This is the messy physical or conceptual universe that a software is trying to model. Think about credit card networks with their complex clearing processes, warehouses with their physical inventory and logistic constraints, human behavior with all of its unpredictability, and business processes that evolved over decades. This layer is inherently complex and often contains edge cases that we don't initially consider. The second layer is abstract state. This is where we take that messy real world and distill it into a clean graph of domain concepts that we actually care about in our software. For example, we might model an order process as pending transitions to paid transitions to shipped. This abstraction is where we make decisions about what aspects of reality we are going to model and what we are going to ignore. The third layer is concrete state. This is where the rubber meets the road. These are the actual data structures we use in memory or store on disk. We're talking about classes, database tables, JSON blobs, and all the technical implementation details that make our abstract model real. The fourth and final layer is interpretation. This is the code that actually uses those data structures to do the useful work, rendering user interfaces, enforcing business rules, sending emails, and all the other behaviors that make our software valuable. Here's my rule of thumb for healthy state modeling. Aim for a one to one mapping between your abstract state and your concrete state. When you achieve this, interpretation becomes a mechanical consequence rather than a complex, compensating dance around inconsistencies in your model. Now, let's get to the heart of today's session. MIRO is a diagnostic framework I use for identifying state modeling problems. It's an acronym that represents the four most common ways your data model can lie to you. M stands for missing state. The soundbite here is we forgot a branch. This happens when the real world can enter a situation that your model simply cannot express. I stands for illegal state. The soundbite here is that combination must never exist. This occurs when your data structure allows combinations that violate your business rules. R stands for redundant state. The soundbite is two fields say the same thing. This happens when you have multiple pieces of data that encode the same information, creating opportunities for inconsistencies. And O stands for overloaded state. The soundbite is one value means two stories. This occurs when a single value in your system represents multiple different realities. Each of these faults has predictable assumptions, specific production consequences, and thankfully, specific refactoring moves that can fix them. In the next lecture, we'll explore each one in detail.